So guys, we'll start in another 2-3 minutes. Actually, just to update you, I had some urgent meetings, so I couldn't make it early today. So that's why I updated and postponed it for 1 hour. So we'll start at say 6 after 2 minutes. Nitika, I didn't get time to do that, but I'll tell you if this error is related to Visual C, C++, as I told you earlier also, please download the Visual Studio or Visual C++. So do you have Visual C++, Nitika, on your machine? Please go to the Microsoft's website and download Visual C++. That might help you. If not, then we'll check. Meanwhile, I'll wait. Guys, please ping on the group if more people are joining in. We'll wait for at least few more people to join in. Okay, so guys, I'm starting, and the agenda for the day is okay. I think 15 people are there. Okay, so the agenda for the day is we are going to do hands-on on neural networks for regression and classification, as we discussed yesterday. So today we will be working on implementation of the models in multiple ways. We will see the use of the activation functions and the different ML frameworks like Keras. And then in the next class, which is next week, we will start with RNN and the LSTM, okay, which is for the natural language processing or any time series data. And then we will do CNN for the images. Okay, so to start with, if you can see my screen, there are multiple ways of implementing a neural network, and neural networks can be done for regression classification. However, you should not blindly start with a neural network for regression classification. You should first see the existing models, try to tune their hyperparameters, do the regularization and all. But still, if there is any issue, you don't see the good accuracy, then you should go into neural networks. Yeah, Gulzar, tell me.
एक्चुअली अभी ये एमएलपी रिग्रेशन शुरू कराने से पहले भी 5 मिनट पहले मैं आपकी स्क्रीन पे कुछ चलता हुआ देखा था, जब मैंने उसी वक्त लॉग इन किया था। वो आपने क्या टॉपिक कराया था तब?
कब कब की बात कर रहे हो आप?
सर अभी आपके ये स्टार्ट करने से 5 मिनट पहले ही।
नहीं, मतलब क्या था मेरी स्क्रीन पे, क्या था मतलब, व्हाट वर यू सीइंग दैट?
सर उस वक्त मैंने लॉग इन किया था, फिर वो फ्यू सेकंड्स के लिए तब विजिबल था तब।
That's fine. I was not telling anything, so ignore it. I was not telling anything to anyone. You may be seeing some model, maybe this model may be running. Okay, yeah. So maybe these epochs were running, so you might have seen those. But yeah, leave that. Okay. So to start with, guys, मतलब regression और classification भी हम neural network से कर सकते हैं. So that's why I want to first tell you that. So what you guys need to do is, first of all, from the sklearn, मतलब sklearn के अंदर भी हमारे पास neural networks हैं, but कुछ restrictions हैं कि okay, but कुछ restrictions हैं कि sklearn library supports only CPUs, not GPUs, for neural networks. Plus, this particular package is good for small data. If you have huge data, millions of records and too many features, this should not be used. Rather, we will be using Keras. Okay. So please import this library and import this. Please import both of these. So guys, I was not speaking something. So there was some, I told you, important things going on today. So I was having email and call from the office. Okay. So that's done. So I'm saying please import this. If you are able to import this, import the first one. This is for sklearn library. So first we will see how sklearn can help you to do neural networks. Then we will do another thing which is keras. So these are two alternatives. या तो हम sklearn यूज कर सकते हैं या फिर हम keras यूज कर सकते हैं. Remember. Okay. So let's start first with sklearn. अगर आप sklearn के थ्रू न्यूरल नेटवर्क्स इंप्लीमेंट करना चाहते हो, they have given these two classes, MLP regressor and MLP classifier. We all know this is multi-layer perceptron regressor, multi-layer perceptron for classifier. So given the data, we have to fit the model, right? But before fitting, we have to know about certain hyperparameters. Okay. So what these hyperparameters are, if you look at, I am creating an object of MLP regressor. Okay. If you create an MLP regressor, this is about hidden layer sizes. It's one of the first hyperparameter, which is saying how many hidden layers we have. 3. Within each layer, how many neurons we have, like 64, 64, 64. So it's like you are doing regression, and for regression you have a black box. Now you are saying add 1 hidden layer, 2 hidden layer and 3 hidden layers, and in each layer how many neurons you want, or what is the size of each layer. There will be an input layer and an output layer separately, but this is about the hidden layers. Okay. Now the question is, how many neurons will come to that, Karan? How many neurons should be there in the output layer? First of all, you have to decide that. And what should be the input size? Means how many features you are going to have in the input. First of all, that's important. Okay. So whenever you talk about regression, you will have certain features like x1, x2, x3, x4, x5 like that. So that will decide the input size. Okay. जो आप input layer देखते हो, जो मैं कहता हूँ कि कोई layer होती नहीं है, but वो दिखती है एक input layer, तो उसमें जो आपको nodes दिखते हैं, वो आपके features होते हैं. Okay. तो पहले तो these nodes will be the number of features. First thing. Second is this thing. आउटपुट लेयर में कितने न्यूरॉन्स होंगे. अब क्योंकि रिग्रेशन की बात कर रहे हो, मान लो आप क्या प्रेडिक्ट करना चाहते हो. आप प्रेडिक्ट करना चाहते हो कि मेरी फॉर एग्जांपल किसको कितना लोन देना है. ठीक है. बेस्ड ऑन द फीचर्स ऑफ अ पर्सन, आई वांट टू डिसाइड कि इसकी लोन एलिजिबिलिटी कितनी है. तो दैट मींस so that means this output will be what? This output will be only a continuous number, and that will be only 1 neuron. तो पहले इतना याद रखो. For classifier, we can have multiple neurons in the output. We will talk about that. But पहले इतना याद रखो कि जब आप रिग्रेशन की बात करते हो तो आप क्या प्रेडिक्ट करना चाहते हो कि अमाउंट, एक सिंगल वैल्यू, तो मतलब सिर्फ एक न्यूरॉन, और वो आपकी कंटिन्यूअस वैल्यू आउटपुट देगा. ये हमें पता लग गया. अब आता है क्वेश्चन कि कितनी हिडन लेयर्स हो और हर हिडन लेयर के अंदर कितने न्यूरॉन्स हो. तो आइडियली यू शुड स्टार्ट विद 1 हिडन लेयर, एंड देन you can start with minimum 2 neurons here and see the accuracy. If the accuracy is not good, increase the number of neurons. If you further want, increase the number of layers. More the neurons, more the layers, more the accuracy, but more the chances of overfitting also. So you need more and more data also to make sure that your model is not getting overfitted. Plus आपको ये भी ध्यान रखना है कि आपके पास इतनी कंप्यूटेशन पावर है. ठीक है. तो ये 64 तो बड़ा ही बहुत ही ज्यादा वैल्यू है. I'll decrease before running it, but I'm telling you, you start with 2 neurons, 4 neurons like that, depending on the problem statement, computation power, and the amount of data that you have. You have to decide these things, but there is no formula as such. However, there is one thing which is important, is whether you are doing a linear model or a non-linear model. If it's a non-linear model, prefer to use minimum of 2 layers, because one layer may not be able to fit that good to the non-linear data or the non-linear problem. For example, you have a support vector machine radial basis function, right, which is there to fit non-linear data. So if you have that kind of problem and you don't want to use RBF and SVM, so you use a neural network with minimum 2 layers, so as to make sure that the fit is good on non-linear data. Okay, but you will learn more about these things. So now you know what should be the input size, what should be the size of this, and there are multiple factors that decide the number of layers and number of neurons, including the computation power. Okay. Then comes the next thing, which is activation function. So which activation function you really want to use? So I am saying I want to use ReLU. I can specify the activation functions different for each layer also. Okay, we will see that. But currently we are setting it ReLU for all. Then ReLU, we know it's a rectified linear unit, and ReLU's graph goes something like this, right? मतलब इनपुट अगर 0 या उससे कम है तो ये 0 रहता है, बट उसके बाद it shows a linear curve. So if your x is 1, y is 1. If your x is 2, y is 2. It's like a linear slope. Okay, 45 degree के angle पे. So if that's how this function works. ReLU function works. It's a rectified linear unit. Random state is just कि मॉडल जब ट्रेन होगा तो जो वैलिडेशन स्प्लिट्स करता है, राइट? नॉर्मली भी जब आप कोई भी रिग्रेशन मॉडल चलाते हो तो इंटरनली, आई टोल्ड यू राइट, ट्रेनिंग डेटा स्प्लिट्स इन 2 पार्ट, one which is actually used for training and another which is for validation. So random state controls these kinds of things. कि आपका जो validation data set है वो कितना होना चाहिए out of the training data that you set in the model, और वो हर बार same ही use हो. That's where random state helps. Maximum iteration as in how much epochs you want, as in how many times you want to train this particular model. So 2000 again is a huge value. We can start with 100 and then increase it. Okay, so that's the first level of things. Once we are done with this, then we have to do what? We have to fit the model. 1 second. Yeah, Aditi, correct. We'll see about these things in detail. Just go here. So we will see everything here in detail. So if you look at like hidden layer sizes, activation function, solver, so we will talk about each of these. Let's go one by one. So it's, for example, how it's happening is your ith element represents the number of neurons in the ith hidden layer. So what that means is I can have multiple layers with different neurons in those layers. Default it's one layer, okay, one layer with say 100 neurons in it. But this is something which is now important, is the activation function that you are going to use for your hidden layers. So that can be an identity function, logistic, 10H and ReLU. So the another problem with the sklearn neural network is it only supports this many activation functions, but yesterday we discussed that there are multiple others, right? Like you have softmax and soft plus, all those which are not available here. But logistic is here, and sigmoid function is a kind of a logistic function. So this sigmoid thing actually is the logistic function. If you look at the formulas, identity function or this activation function, identity activation function, is nothing but that linear function which I was talking about yesterday. F of x is equal to x. Yeah, f of x is equal to x. Logistic is nothing but your sigmoid function. Okay, the logistic sigmoid function. And then you have the hyperbolic 10H function, and you have the ReLU. ReLU's formula is max of 0 and x. I hope this is clear, because what this is saying is the ReLU function, which goes like this, and then it goes like this, means its value can be maximum of either 0 or x. तो अगर यहां पर मैं देखूं तो यहां पर x की वैल्यू मान लो है -8, तो which one is maximum? 0. So line is like 0. So it keeps on going 0, 0, 0, and as soon as it reaches here, so x is 1. So between 0 and 1, what is maximum? It will give you that value. If it is 2, so between 0 and 2, what is the max value? It is 2, so it will give you y as 2. So is it clear, guys? Rectified linear unit. They may ask you difference between a linear function, which is this one, and the rectified linear function. So this is rectified as in, अगर आप इस function की बात करो, तो ये function will go like this. It will also give you negative values, right? But ReLU will just go on the 0 axis for values lesser than 0. Okay, so that's the difference between this and this. एक तरह से इसको आप नो ऑपरेशनल एक्टिवेशन भी कह सकते हो, बिकॉज ये कुछ कर नहीं रहा, जो इनपुट दे रहे हो वही आउटपुट दे रहा है. आइडेंटिटी फंक्शन होता क्या है? जो इनपुट दे रहे हो वही आउटपुट दे देता है आपको. मैक्स टू मैक्स कुछ बायस ऐड हो जाएगी, बट जो इनपुट है वही आउटपुट आ रहा है. So we have identity function or the linear function. We have sigmoid or the logistic function. We have hyperbolic 10 function, and we have the ReLU functions. Okay. Okay. Then comes this thing, which is another very, very important thing. So we are building a regression model, and we talked yesterday that ठीक है, यहाँ पर मैं 3 layers की बात कर रहा हूँ. हर लेयर के न्यूरॉन्स मुझे पता है. मान लो इसमें 2 हैं, इसमें 3 हैं, और इसमें भी 2 हैं. ओके, सो ये मेरा हिडन लेयर का साइज हो गया. ये मेरे हिडन लेयर के एक्टिवेशन फंक्शंस हो गए, राइट? बट देयर विल बी अ इनपुट लेयर, and then there will be output layer. Because it's a regression, so it knows that there will be 1 neuron in the output layer. It don't ask you to put that, it assumes it. Okay, and if it's a classification or a classifier, then the number of neurons in the output layer depends on the number of classes. If there are 2 classes, then 2 neurons in the output layer. 3 classes, 3 layers in the output layer. That's how it works. We'll talk about that. But currently you look at regression, you defined the hidden layers and hidden layer activation functions. but output layer you don't do anything because it's a special case of MLP regression which decides itself what should be the output layer. But now the question is, we have to train the model. That means we have to do back propagation. So back propagation is what? Your gradient descent. So the gradient descent is something that you want to do 2000 times. So back propagation that you want to do that 2000 times. That's what you are doing, gradient descent process 2000 times. Okay. See, there is no forward propagation. It's feed forward network which moves everything in the forward direction. Okay. So just understand that it's a feed forward network. Back propagation is a process of gradient descent which is to adjust the weights. So don't confuse it like forward propagation and backward propagation. Model is a feed forward network. It's not a cycle or a loop. Yeah, it's not a cycle or a loop like RNN or LSTM. But the question is how your weights are getting adjusted, how your gradient descent is happening. So that's where your iteration come into picture. And since you are doing gradient descent process, now solver, right? You remember in other sklearn models you are using solver. So the question is which solver you want to use. So we should prefer what? We should prefer SGD. Can anyone tell me the full form of SGD? वो स्क्रीन पे दिख गया वैसे, but can anyone tell me SGD की full form? Stochastic gradient descent. Yaditi, yes, correct. Pragisha, good. So we prefer stochastic gradient descent. So now देखो gradient descent तो आपको करना ही करना है, but उसको करने के भी अलग अलग मैथमेटिकल अप्रोचेस हैं. तो ये तीन वो अलग अलग मैथमेटिकल अप्रोचेस हैं. One is stochastic gradient descent, like there is a gradient descent, there is a mini batch gradient descent and stochastic gradient descent, right? I asked you to read about it, right? Like stochastic gradient descent is fast than other gradient descent processes, but it has its own problems. Then there is Adam optimizer. You must have saw the Adam optimizer I was talking yesterday. So Adam optimizer is like another mathematical approach of doing the gradient descent only. So this is also doing gradient descent, this is also doing gradient descent, but the mathematical process is different. So you should use SGD, which is best. However, Adam optimizer is equally good. Okay, so when you have large amount of data, use SGD and Adam. Okay, but when you have a small amount of data, you can use LBFGS. LBFGS, as we were talking, it was limited memory BFGS, which was one of the things we discussed even in the logistic regression. And this internally uses certain concepts of Hessian metrics. Okay, it uses the concept of Hessian metrics. So it actually optimizes this Hessian metrics, but we should focus on SGD and another advanced SGD, which is Adam optimizer. It is also a stochastic gradient based optimizer, but proposed by some other statisticians or modelers, and it has more optimized way of working. So when you have huge amount of data, prefer these two. When you have lesser data, prefer this one. So even if you look here, it works pretty well on relatively large data sets, like thousands of training samples. For smaller data sets, you can use this. The another thing is alpha. So because it's a regression, we can do regularization. Here we can do L2 penalty. Okay. So if you want to do L2, can anyone tell me L2 is what? Ridge or lasso? Guys, now you should remember all this, right? Ridge, very good. So if okay, can anyone tell me what will be the impact of doing this? अगर मैं L2 penalty सेट करता हूं तो ये मेरे ग्रेडियंट डिसेंट प्रोसेस में किस चीज को इम्पैक्ट करता है? नो, ग्रेडियंट डिसेंट प्रोसेस में जो आप करते हो, नो, ये किस चीज को सीधा सीधा इंपैक्ट करता है? नहीं, ये आप लोग तो मुझे आउटपुट बता रहे हो, बट ऐसा कौन सा चीज है जिसमें जाकर ये सीधा सीधा फिट होता है? किस फॉर्मूले में जाकर ये वैल्यू सेट होती है? आप तो आउटपुट बता रहे हो मुझे इसका। वेरी गुड करण, या कॉस्ट फंक्शन, वेरी गुड। लॉस फंक्शन, या करेक्ट. So this alpha parameter actually changes your loss function. When I say changes, means if your loss function or the cost function is SSE, squared sum of errors, or say cross entropy, whatever, it adds what? Alpha times that norm of W square, right? Remember, norm of W square, your weight square. So this is the additional part which get added to your cost function. This is for ridge. For lasso, it takes the absolute values instead of a square. Okay, guys, yaad aaya ye? Are you able to relate it? This, your cost function will change. That's where your process of gradient descent will change. Your final outputs will change. And regularization penalizes the higher weights, right? The higher slopes. So guys, are you able to recall this? Yes or no? Okay, perfect, perfect. So remember what the impact of setting this value, where it's going to impact. First is where it's going to impact, and second question is what is the impact. So when you say what is the impact, then it is your weights will be adjusted, or it's going to handle the overfitting and all, right? Acha, should it be high or low? Should the penalty parameter be high or low? Okay, can you tell me, guys, should be high or low? If I have to do regularization, uh, should I set it higher or should I set it lower? Guys, it should be high. The more the penalty you want, the more higher its value should be, right? The closer it's to zero means you're not doing regularization. It's like that overfitted model. Okay. But in some models, they use C parameter, which is inverse of alpha. So there it becomes ulta, but then you know कि मैं किस चीज की बात कर रहा हूं, मैं पूछ क्या रहा हूं. Batch size. So ये कल भी आप लोग देख रहे थे, batch size बार बार. I told you hold on to batch size, right? So what is batch size is during each iteration, that gradient descent optimization, how many records should take part in the optimization. So size of the mini batches for stochastic optimizer. If solver is LBFGS, the classifier will not use this because LBFGS is a different process altogether. However, if it's SGD or if it is Adam optimizer, then you can set the batch size to 1 or 10, 100, whatever. But it should be minimum of 200 or a number of samples, means optimal value for batch size is 200. Okay. So guys, you are clear with what batch size is? Yes or no? Okay. Okay. Batch size is, Tanya, I'm saying you build a model in a feed forward way, but then you adjust the weight in the backward propagation. So say you did one backward propagation. So your weights get adjusted, right? But to adjust those weights, how many records from the total records you are using to adjust the weights or to do your mathematical calculation? So if you have 1 million records, do you want all the 1 million records to be used? It will be very slow. What I mean to say is, when you do say forward, you get certain errors. Okay, you ran it for say 1,000 records, you get 1,000 errors, like the delta difference between actual and observed. Now out of these, you use only 200 records to run your weight adjustment process. Then in next iteration, you may use some other 200 records. Then in another, you will use another 200. That's where your gradient descent process will run every time on a subset of data, not on the entire data. That's what is the concept of mini batch gradient descent, or even the stochastic gradient descent. Okay, Tanya? This is the number of records, Aditi. Number of records, total number of records. So ideally means अगर आपके पास रिकॉर्ड ही 10 हैं, मान लो रिकॉर्ड ही आपके पास 100 हैं, तो आप बैच साइज 200 का दे ही नहीं सकते, राइट? क्योंकि it should be a subset of the total records. Learning rate we will keep constant throughout the model. Even learning rate can also be changed. Okay, there is this adaptive learning rate, but currently focus on constant learning rate, which I was telling you yesterday. The parameter which is used to adjust the weights, it's the learning rate. So you can set up the learning rate. Okay, here you can set up the learning rate. So you are setting the initial learning rate to be this 0.001, 0.003. These are the optimal values. But if you make it adaptive, this thing, then neural network can change during multiple iterations. This value can change. And then this is maximum iterations, is कितनी बार आपका मॉडल चलेगा. Random state, which is another important thing. Verbose, which is just to print the outputs on the screen. Warm state we'll talk about later if needed. It's a separate topic. Early stopping is something important. So Karan, these initial weights are random weights. System can set up anything randomly, or even if you want, you can also set up a matrix. So you can also pass on. For example, if I talk about this, these are your hidden layers. So you need to set up a 2x3 matrix. You have to set up those values 2x3 ka matrix and pass that initial weights. That can also be done. Okay, I'll show you. Like linear regression also, right? In linear regression also gradient descent happens, and there also some initial weights are assigned before starting the optimization. So it's similar to that. And there also, even in linear regression also, we can set the initial weights. Okay, but models purpose is to make sure that initial weight जो भी रहे हो, finally they will be either increased or decreased to get you the minimum error. So this early stopping is another important thing which specifies when to stop training the model, because sometimes your model will keep running and running unnecessarily. So early stopping इस तरह से समझो कि आप मॉडल को बोल देते हो कि भाई, हाँ, आप मॉडल को बोल देते हो कि अगर एक आइट्रेशन के बाद दूसरे आइट्रेशन में जो मेरा लॉस फंक्शन की वैल्यू रिड्यूस हुई, पहले मान लो 0.2 थी, फिर वो 0.1 हो गई, आप कहते हो इतना कम डिक्रीज होना इज नॉट व्हाट आई वांट. Let me type in. First epoch gives you the loss function of say 0.23. In this another iteration you get 0.19. Okay, the loss function is decreasing. The difference between the two is 0.04. Okay, but one of the early stopping criteria like that your model may use is, if you set up these, is say 0.05 is a minimum of the gain, I would say, that the accuracy, so not accuracy, sorry, the loss should decrease by a minimum of 0.05 factor for the iterations or the gradient descent to continue. Otherwise, it will not continue. So I'm giving you an example of how early stopping works. But there are multiple things other than this. But are you getting this first of all? Because this early stopping is a very in itself a detailed topic, but are you able to understand what I'm saying here? Can anyone tell me where else we talked about this? Yeah, Vipul, absolutely you are right. Then it may so happen that you don't reach the convergence level that you were interested in. CP decision tree, yeah, definitely, guys. In the decision trees also we used these stopping criterias, right? Okay, so let me just close it before we go ahead. 1 minute, guys. Give me a minute. Okay. Let me check if there are any questions. Okay. So does each model support some limited solvers, like in the logistic we had 5 solvers? So Anand, question is, does each model gives limited solvers? Definitely yes, because it's some mathematics which is involved in a solver. So it may not happen that each model supports all of them mathematically. It may be that कि उस पे research चल रही हो, but yeah, even if someone of you know about Spark is another field in big data. Okay, it's another field of big data where we have Spark ML, Spark based machine learning. So even Spark ML does not support everything. Okay, yeah, it's better, Anam, yeah, guys, to ask questions publicly because other people get it. So there are multiple reasons behind it, Anam. Okay, to give limited solvers. Some of them are not supported because of mathematical limitations, or for some they must be working on. So that's the thing. Okay. So now what we have done is, say we have built a MLP regressor, pass on all the parameters, we will fit the model, whatever we have, say X, and then we have say Y, X train and Y train. Then we will predict using the X test. So I'm saying this is another field of machine learning, like those of you who may know Spark ML. So what happens is, जैसे आप आर से मशीन लर्निंग कर रहे हो, पाइथन से कर रहे हो, वैसे ही और भी तरीके हैं मशीन लर्निंग करने के. तो मशीन लर्निंग लाइब्रेरी given by another company, which is even Apache Spark. So Spark is a framework, another framework, uh, which is a big data framework that supports machine learning. Okay, but it's not something like Keras or TensorFlow. Don't compare it to that. Those are deep learning frameworks. Spark is a big data framework. Okay, Spark is a big data framework which supports machine learning. And here the languages that we use is Java or Scala. Okay, Java or Scala. These are different languages that we use here. So that's what Spark ML is. We can use Python also here. Okay, but what I'm saying is, you see here, you have clustering, you have classification and regression, you have collaborative filtering, pattern mining, everything is available here. Machine learning pipelines, so everything can be done. Okay, so it's like, see, why we need Spark is, normally when you run your models, you run it on a single machine. But in real world, we want to run model or train a model parallelly on thousands of machines, because in real world we have millions of records. So Spark runs your models in a parallel fashion on multiple machines. Consider it like this. So if you have to run your model, a machine learning model on a single machine, you can use a Jupyter Notebook or R Studio. But if you have to run a model on thousands of machines parallelly, okay, मान लो आपके पास 10 मशीन्स हैं, हर एक के ऊपर 1-1 मिलियन रिकॉर्ड्स पड़े हैं ट्रेनिंग डेटा के, और आपको उस मॉडल को इस सारे डेटा के ऊपर ट्रेन करना है. तो आप एक ही बार में स्पार्क को बोलोगे कि भैया ये मेरा मॉडल है, इसको इन 10 मशीन पे पैरेलली ट्रेन करो. हर मशीन के पास अपना अपना डेटा है, तो single machine will train it on 1 million, another on another million, but the model will be trained on totally 10 millions of records. Okay, so that's the power of Spark. Okay, Nitika. So it's a Spark machine learning library which is running your models on clusters, okay, on multiple machines parallelly, which speeds up the performance actually. Okay. So finally, you simply do fit as you do fit, nothing, no rocket science. You do the predict as you normally do, you calculate the R2 score. Okay, so we will now take one data set and we'll be doing this activity. I will share this data to you guys. Okay. So literally you can take any data here. So first of all, let me try to create some dummy data. Okay, I'm just creating a dummy data before taking a use case. So guys, just run this command and see if it's running. Okay, so guys, what I'm doing before we jump into the actual data set, so I'm creating some data for you. So now here we have to actually talk about data in terms of arrays, okay, or metrics rather than data frames and series, okay. So here if you look at what I'm doing is, this is one row, this is another row, two rows, this is column 1, column 2, like column 1, column 2. So I'm passing on two features and two rows. This is my output data, which is a continuous numerical variable, which I need to predict. Now I am just using the fit to predict that value. My model is running. It ran. And then I have to predict. Okay, I have to do the prediction, but before prediction, I need another data. So let me pass on some data to my model. Okay, I need to import this metric. Okay, so before we go into that, so what you need to do, first of all, you have to have a problem in hand. Okay, any problem, for example, any continuous numerical problem we will take. And then we will see our data and make sure it's in the form of your features and the target. So what I have done is, for the time being, I just created a train data like this. So it's like you have this as your feature set, which is your x1 and x2. These are two features, and this is the target that you want to predict. Okay, so this is my row number 1. Okay, Anam, I hope you got it now. This is my row number 2, and this 22, 34 is value 22 and 34, like that. Okay, okay, Anam. So that's what my data is, and then I'm just fitting my model. That's it. So when I'm fitting it, this model is running this to use, and even after 2000 iterations, it haven't really converged. Okay, it haven't really converged. So we can do multiple things here. Definitely we can increase the iterations, but before that we will see our optimizer, we will see the batch size. Okay, a lot of things are there before increasing iterations. We can increase the batch size and see what happens. And then once I have trained this neural network is built. Okay, and how it is built, you will see here. Okay, there are two layers, 2 and 3 neurons in that, and it's done. Now I am going to test it with some data, and I'm using it to predict. Now if you see, it's predicting this. Yeah, so it's predicting 8.75 and 8.75 for both of these inputs. And if you see, मैंने जो input है वो same ही दिया है जो ऊपर था. तो values see 22 and 34. But this model has really done very bad. 8 and 8 and same values even, right? So that means, first of all, it's not like neural networks are always good. But the another problem here is we didn't had enough data for model to learn. Definitely this model couldn't learn much from these two records, which is another problem. But yeah, definitely this model is behaving quite bad. So we need to increase the number of records, which is the first thing. And here why it's failing is because I need to do this from sklearn dot matrix. You need to import R2 score, right? So you will import this, and then probably this should run. Yeah. What happens sometimes is you take it in the notepad or notepad plus plus, put it here. Okay, cut it back, put it back. Even the R2 score is coming 0. Quite weird. Okay, so what we have to do here, guys, we have to first of all increase the data and run this model on some good data. So what I'm taking is, so I have a data, I have some data from Chennai reservoirs. So what this data is, I'll tell you. Let me show you this data. Okay, so this data is actually trying to solve the water problem for Chennai, where Chennai recently faced say water problems. So we have the water reservoir levels. Like there are 4 water reservoirs in Chennai. One is Pondi, one is Kolavaram, one is Red Hills, and one is Chembarabakulam. How is it? So what we have to do, we have to use these 3 features, which is Pondi, Kolavaram, and Red Hills, like the amount of water which is in this 3 reservoirs, and use that to predict how much amount of water will be in this last reservoir. So this last reservoir is something we have to predict the water amount, but for others we are given the data. So first, this is one of the problem. You can use any problem. Okay, this is one of the sample problem. There is this date column, but you can ignore the date column because we are not doing any kind of time series analysis here. But if we want time series analysis, that can also be done. Okay, so यहाँ पर हम time series analysis भी कर सकते हैं क्योंकि time है हमारे पास कि with the time how the water is varying in different reservoirs, but we are using only one. This we are just dropping this date column. We will not need it. And instead of doing pandas.read CSV, we will use NumPy because mathematically neural networks, they need arrays and metrics, right? Because of the volume of the data and mathematical formulas they work on. So we will use NumPy load text function, np.load text. This is the CSV file. I'm specifying the delimiter. It's a pipe separated file. I'm asking to skip the first row because that's where the columns are. And I'm saying only interested in the columns 1, 2, 3, 4, not the 0th column. 0th column is date. So I'm dropping the date column. So if you look at, this is how my data is in the form of matrix. So I can see the shape of it. So these many records I have, 56, 47, and then 4 columns. Yeah, Gulzar, problem means crisis. Yeah, you can say that. But not all problems are crisis actually. There is a difference. Okay. So this is the shape of the input data, but now what I need to segregate it in the features. Yeah, water problem or water crisis. Yeah. So now we will split it into 2 data sets. One is the features, all rows, and 0 to 3rd column, and the last column, 3rd column, exactly will go as my target. So given any data, you need to make sure it's in the array form, not in the form of data frames or series, and that's it. Once you have this, you are good to go ahead and implement the model. So let me take this data out. Okay. So what I'm going to do, I'm going to do this thing here. So we have already set up the model. Now the only question is to fit and predict. So I'll just put all these things here. Okay. So now, and also let me put verbose here. So अगर आप देखोगे verbose करते ही difference क्या आया? You can see that it's printing me everything. We will see that. Okay. Perfect. Okay guys, so by now आपको एक फाइल दी गई है, उस फाइल को आपने लोड कर लिया, जो कॉलम्स काम के थे वो रखे, बाकी हटा दिए, फिर इसको फीचर्स और टारगेट में आपने स्प्लिट कर लिया. एरे की फॉर्म में सारा डेटा होना चाहिए बिफोर यू स्टार्ट द फिटिंग प्रोसेस. That's one thing. The another important thing is scaling. We need to make sure we scale our data even before neural networks, because here also the gradient descent process is running, and we want to make sure each feature is on the same scale. But now we will see whether it's underfit or overfit, and based on that we will decide कि हमें regularization करना है या नहीं. तो regularization अभी हमने नहीं किया है, अभी हम सिर्फ अपने मॉडल को ट्रेन कर रहे हैं without regularizations. Yeah, Nishtha, you can handle all those things. Outliers, duplicates, missing values, everything. So that you can do separately. Everything you have to do. Matlab, neural networks, they are good to some extent. They do a lot of EDA for you, but not all neural networks do it. At least not these MLP ones, the sklearn ones. There are advanced neural networks which handles missing values and certain level of other EDA aspects. Okay, but not all neural networks do it. But that's the beauty of neural networks, the advanced neural networks, that they do much of your EDAs. However, you should still do scaling. Scaling is a must. You should not leave it to the model. Maybe missing values you can leave it to the model, but not the scaling. And that too also depends on the advanced neural networks, not these basic neural networks. Okay. So now what I need to do, I need to fit the model. This is my neural network. I am fitting it on the data that I have. So as soon as I fit, I ask for 2000 iterations. So this will run 2000 iterations. It starts with the loss function value as, or the SSC value, the squared errors. Your model can use, guys, your model can use SSC. Your model can use SSC. It can use MAE. You can use any of these as your cost function. Remember that. ऐसा नहीं है कि squared sum of errors use होगा. MSC, MAE कुछ भी use हो सकता है. But again, basic models may not allow you to tune everything. But as you move into the advanced models, they will allow you to tune more things. Okay. So advanced neural networks, as in Gulzar, I'm saying the advanced packages. You move from, currently you are seeing sklearn. If you move into Keras, if you move into TensorFlow, or you move into another advanced frameworks, they may handle these things for you. Okay. So it all depends on the libraries that you are using, whether that library itself is having that things implemented. Okay. But what we are doing is the MLP model, which is the multi-layer perceptron. Okay. So advanced neural networks एक बहुत ही वेग टर्म है, बिकॉज एडवांस की बात जब हम करते हैं, मैं ये भी कह सकता हूँ कि CNN and RNN are advanced, but I'm not saying the package that you are using. Currently I'm using sklearn. If you use Skera's package, so that may be advanced in as compared to sklearn, तो वो फिर एक अलग बात हो जाती है. Okay. So currently I'm using the basic package for neural network, which is sklearn, which is not even suggested. Okay, but you should know, right? That's why. So now you will see your loss function is decreasing. It kept decreasing up till 2000 iterations. It will run and try to converge to a particular point. So here the error is 203, but again it's not converged. So you can play with other hyperparameters. I was saying the batch size, you can increase the number of layers, you can increase the number of neurons, but before doing all these things, try to increase the batch size, change it to Adam optimizer, because that may be better as compared to other optimizer. So first try those. Once we are trained the model, once we are done with that, we can see certain parameters of this model. हर मॉडल के जब मॉडल ट्रेन हो जाता है तो हम कुछ पैरामीटर्स देखते हैं, राइट? So those parameters are like which activation function was used. Okay, I'll say I used ReLU, but this is something important, the coefficients, right? One second. So what this coefficients indicates, to understand that you have to build your model. So what your model is? Absolutely, these are final weights. I'm building the model. And then you have one output. And then we had how many features? 2, 3 features, right? So just I'm trying to fit this in. So let's see how this will be fitted in. Okay. So if you start with this side, if you start with this, the last one, so it's this weights, 3 weights. Okay. So these are these 3 weights that you got. Okay. Then you will see these are the 6 weights here, right? So how many connections you have? You have 6 connections, right? So these are the weights for these 6 connections, like W1, W2, W3, W4, W5, W6, like that. So these will be my 6 weights. Okay. And now these are the weights which are coming from here. Okay. 1, 2, 6. So this should be 6 weights. Okay. It may so happen that one of the features might not have played any role in this. So that's why initially only 4. Let me check that. Okay, so this is potentially the reason of one of the features not playing an important role. 1, 2, 3. Okay, what are these intercepts? Before I go into that coefficients again, I'll tell you those coefficients. What are these intercepts, guys? Those coefficients are your weights. What are these intercepts? Any idea? Yeah, Nitika, absolutely correct. So I'm again plotting this. 3 inputs, 3 layers, 1, 2, 3 here, and 1 as the output. I'm coming to that, Nitika. But before that, let's see the intercepts, how many intercepts we have. So intercepts are like the bias, right? So this is the bias at this neuron. This is the bias at this neuron. These are the biases at this layer. So this is your layer 1. This is your layer 2. And this is the output layer, the final layer. So final layer also have some bias. Okay. So these are my biases which are coming at each neuron. Okay. These are my biases associated with each neurons. These are the biases at this layer, and this is the bias at this layer. But now going back to coefficients. Okay, I'll explain. You guys please come up till this level. Please ping me if you are up till this level. Are you able to run this, get the coefficients and the intercepts? Yeah, Vipul, it so happens that the weight becomes 0 for some of the features during multiple iterations or back propagation. So what I'm saying, guys, is this bias, right, which was getting added. So that was your intercept. But here bias like B1 was here. You can say there was another bias which is different for this neuron. And here there was one bias at this level and one bias which can be different at this level. In this particular chart, it's saying bias is same, but not in our case. Yeah, Karandeep, output layer also have the bias. Bias, just consider it like wherever you have certain computations, bias will come in. Wherever you have the activation function, okay, that's running in, the bias will come. So bias will come because activation functions are here also at each layer you have that. So that will happen. Guys, please up till this. Okay, you can take, see, you can take any data. If you have done regression earlier, right, take that regression data. It's fine. You don't really need the same data that I have. Let me open it up. Open any linear regression problem that you have done in the past. Use that same data and then do it. So there are a lot of inbuilt data sets available in sklearn. You can even leverage those. Even you can use this data also if you have some insurance data from my file. Use this insurance data. If you have this in the form of pandas, you can also convert it into numpy arrays also.
Excuse me, sir.
1 second, Gulzar. 1 second. Yeah, Gulzar, tell me.
सर अभी आपने जीरो वेट के बारे में कुछ कहा था अभी थोड़ी देर पहले भी.
हाँ हाँ बिल्कुल. 1 minute. Guys, please import any of the CSV file that you have. Import any of the CSV file using that np.txt function, and please do this. So Gulzar, what I'm saying is during the gradient descent process, what may so happen is you are adjusting the weights, right? So it may so happen that say you did the feature importance, right? The kind of analysis whether that feature was really important or not. But while you are doing the back propagation and adjusting the weights, for some of the features, weights may go down to 0. specifying that those features were not important, and that's what I was saying by saying weights can go to 0. Okay, that's the concept of any gradient descent process that happens. Some may bring it near 0, some makes it 0. So guys, please ping me if you are able to do it using any of the file, any of the insurance file or whatever file you have. Just read it using np dot, that function that I pinged you guys. I don't have this insurance CSV file. Let me check. Or if you want, I'm putting this file on the GitHub right now. If you want, take it from there. So guys, this file is there. You can take it from my GitHub account. Under the data files, you will get it. Okay, this file is uploaded. Please take it. Once you take it, download it to your local and run this program. Or I'm pinging you this. You can use this also. I'm pinging you this, so you can use this data also. If you don't want to do that, so this is the diabetes data where we have certain features and then we are predicting the level of diabetes. So data set dot data. So this data, see, that's why the stored data sets are in the form of this particular arrays, so that you can directly use them. And this is your target. So this is the target, so we can directly use this data. So guys, I'm pinging you, please use this data first. Run your model. So I am also changing my data for you. Then we will again talk about that coefficient and intercept, because वही सबसे important part है पूरी modeling process का, कि आपके weights क्या बन रहे हैं. Okay. So guys, please confirm me if it's done. Okay, okay, Karan, thanks. So just try to understand your coefficients which are getting printed, Karan. So these many are the coefficients. So it's like you have 2, and then you have these 3, and then you had this 1. Okay. Okay. So this is so guys, how to interpret this is a different दिखाने का तरीका अलग है, but this is how it's being represented here. This is your first feature, and for that, what's the weight with this and what's the weight with this? Okay, this is your another feature. What's the weight with this? What's the weight with this? This is your another feature. What's the weight with this and what's the weight with this? So like that, your all the features are having these connections. Ultimately these connections have those weights. Okay, so you are getting this. This is your feature, one feature. It will have different weight for this, different weight for this. वो अलग अलग जब आप टूल्स यूज करोगे तो वो दिखाने का तरीका ऐसा रहता है अलग अलग. तो ये आपके अलग अलग फीचर्स हो गए. दिस इज इनपुट लेयर, ये आपकी इनपुट लेयर है. तो ये इनपुट लेयर से जो कनेक्शंस बन रही हैं आपकी हिडन लेयर, फर्स्ट हिडन लेयर पे, ये उसके वेट्स हैं. फिर यहां से अब आप ऐसा देखें कि ये आपका ये जो एरे है, ये एरे जो है पहला एरे इस वाले न्यूरॉन का है. इसके 3 कनेक्शंस बन रहे हैं आपके 1, 2 एंड 3. तो ये 1, 2 एंड 3 इस तरह से वो उन वेट्स को सिग्निफाई कर रहा है. सिमिलरली ये सेकंड न्यूरॉन है तो ये उसके वेट्स नेक्स्ट लेयर पे दिखा रहा है. और अब ये देखेंगे तो आप एरे हैं, तो ये इस वाले न्यूरॉन का इसके साथ वेट, अगला इसके साथ और अगला इसके साथ. तो इज इट क्लियर? Guys, I want all of you to answer. So वो बस रिप्रेजेंटेशन का तरीका अलग हो जाता है. हम नॉर्मली वो W1, W2, W3 वाले फॉर्म में अगर सोचते हैं तो वहां थोड़ा कंफ्यूजन आ जाता है. yes, I am telling you, Tanya. So some tools might show it like layer wise W1, W2, W3, but yeah. So Tanya, first of all, you have to plot the neural network. So we use 2 layers, and first one was having 2 neurons and second was one having 3 neurons, right? Output we didn't specify because it's regression, so there will be only one output neuron. Input layer is not a neural network layer. It just जितने फीचर्स हैं वो यहाँ पर आ जाते हैं. अब मैं कह रहा हूँ ये आपका फर्स्ट फीचर जो है उसको रिप्रेजेंट कर रहा है. तो अगर ये फर्स्ट फीचर है, मान लो एज, तो एज का इस न्यूरॉन के साथ जो वेट है वो ये है. और ये जो एज का वेट है वो दूसरे न्यूरॉन के साथ है, इसके साथ। तो इस तरह से ये आगे बढ़ेगा। ये आपका दूसरा फीचर है। तो मतलब ये वाला फीचर है तान्या, इस वाले फीचर का वेट इसके साथ और इसके साथ, राइट? Likewise you have to follow the approach. आप पीछे से भी चल सकते हैं कि आप यहां से अगर चलें तो वेट विद दिस दिस एंड दिस, देन यहां पर जब आप आ जाएंगे एट दिस पर्टिकुलर लेयर, तो इट्स हियर इट बिकम्स बिट कंफ्यूजिंग देन। मतलब अगर आप पीछे मैप करने की कोशिश करोगे, बिकॉज it's not mapped at this level, rather it's mapped from here like this, rather than from here in the backward direction. It's not, because यहाँ सिर्फ दो ही आपको एरे दिख रहे हैं, राइट? लेकिन अगर यहाँ पर ये दो एरे हैं तीन तीन के, अगर तीन एरे होते दो दो के, तो आप बैकवर्ड वे में उसको समझ सकते थे। वो समझने का एक तरीका है, बट हम फॉरवर्ड में उसको समझ रहे हैं, इसलिए इस न्यूरॉन से तीन वेट्स निकल रहे हैं। सो गाइज, इज इट क्लियर ये वेट्स आपके कैसे दिख रहे हैं यहाँ? Sir, we have defined in the hidden layer 2 3, so they are only related to hidden layer. नहीं 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 करण, देखो हिडन लेयर आप स्पेसिफाई करते हो, बट वेट्स पूरे नेटवर्क के होते हैं। वेट सिर्फ हिडन लेयर के नहीं होते। मतलब अगर सिर्फ हिडन लेयर के होते तो एक तरह से तो सिर्फ दो ही हिडन लेयर थी, तो एक इस लेयर पे वेट्स होते और एक इस लेयर पे वेट होते। मतलब दो ही सेट ऑफ वेट्स होते ना, ये और ये। लेकिन ये क्यों है? क्योंकि वो फिर आउटपुट लेयर जो है आपकी, उसके वेट्स हैं। तो अल्टीमेटली वेट्स आपके नेटवर्क लेवल पे होते हैं, मतलब सिर्फ हिडन लेयर के नहीं होते। वेट्स रादर लेयर पे भी नहीं होते, वेट्स लेयर लेवल पे होते ही नहीं। वेट्स होते हैं कनेक्शन लेवल पे, कि जो कनेक्शंस बन रहे हैं इन बिटवीन द लेयर्स, वेट हमेशा उससे रिलेट किए जाते हैं। ओके, वेट्स आर नॉट फॉर द लेयर्स, वेट्स आर फ्रॉम वन लेयर टू अनदर। दैट्स हाउ द वेट्स आर actually understood. For example, if I'm talking here, so I will not say the weight at this layer or weight at this layer or weight at this layer. Rather, I would say weight at the connection level. So this is one connection, this is another connection. So here you will have two set of weights. Okay. Similarly, in this case, weights are at this connection and this connection level. And further, there is nothing. So you don't say that weights are at the hidden layers, rather weights are between the connections between the layers. Okay guys, till now all of you are with me, or someone is still trying to run it? Before we proceed, I want all of you to run it. Okay, perfect. 200 पे conversion नहीं हुआ. No, so that's what Vipul, you have to change it to Atom Optimizer. Try it with the Atom Optimizer. Increase the batch size and increase the learning rate. Okay, let's do that. Okay, let's do that. Wait. So if we see here, हम देख रहे हैं कि बार बार कन्वर्जेंस वार्निंग आ रही है, कन्वर्जेंस वार्निंग आ रही है। तो कन्वर्जेंस वार्निंग को रिमूव करने के लिए लेयर बढ़ाना या न्यूरॉन बढ़ाना इज नॉट एक्चुअली द right approach. To do the convergence even with the given layers, we have to play with the gradient descent. See, hit where the problem is. The problem is with the gradient descent. So now the gradient descent should be optimized. And how can you optimize the gradient descent? By changing the learning rate, which is the biggest thing. So let's see what was the default learning rate. .001. Very bad. See, this is the cost function curve. This is your cost function curve. You are saying from one point to another during every iteration take the smallest jump 0.001 का साइज. अब मैं 2000 क्या 20,000 कर दूंगा तब भी वो इतने छोटे छोटे जंप लेगा 2000 में, वो बेचारा यहीं तक ही पहुंच पाएगा. लेकिन अगर वहीं मैंने लर्निंग रेट बढ़ा दिया होता तो एक एक जंप वो इतनी बड़ी बड़ी लेता, तो कन्वर्जेंस हो सकती थी. तो लेट्स प्ले विद द अल्फा और वेट सॉरी आई थिंक या दिस इज द वन. सॉरी वो कहीं ये अल्फा तो हमारा वो है. क्या है ये अल्फा? कैन एनीवन टेल मी? ये अल्फा है टू रेगुलराइजेशन. दिस इज द लर्निंग रेट. ओके, this is the learning rate. This alpha is not that, but still this learning rate is very very slow. ये तो आपका L2 regularization parameter है, penalty. तो ये 001 is very very less. So let's increase it. So guys, please make it 0.01. Make it 0.01 and run it. Your learning rate in it, make it 0.01. Reinstantiate the model. So we have this model done. We will fit it on the data, the diabetes data only. So let's fit it on the diabetes data, guys. Okay. Let's see if they're still getting a warning. So I'm not getting the warning, but yeah, those of who are getting the warning, let's see what can be done further. Okay, so we change the learning rate to make it better. We can increase the iterations, which is like another thing. Change the optimizer to Adam. Please change your optimizer to Adam. Just see what all you can do. Okay, solver is already Adam. Okay, so don't do anything. Batch size is auto. Okay. So change the batch size to 10% of your data. So whatever you have the data, the total number of records, put 10% of that here. So if you have 5,000, put like 500 here. Learning rate is constant. This is the learning rate. Verbose is there. I'm not doing splitting. Epsilon is fine. Maximum iteration and iteration, no change. That's fine. See if the batch size is increasing. The batch size is helping you. And then after that, we can also change the activation function. But activation function ReLU is good enough here. So how many records are there in diabetes? Please check that. In the diabetes data, how many records are there? 442. So put like 40 there. So you have to play with these values, primarily the iterations, the learning rate, which I told you, right, which is one of the most important thing. You can make it to 0.03 also, but don't make it further lesser than that. Change your batch size, activation function, and also the optimizer. Instead of Adam, you can try SAG and then see whether it's converging or not. Okay, so that's fine. Means you have to try about multiple approaches here, because doing convergence is not only about the model, it's about the data also. But yeah, you avoid changing the layers for convergence. First of all, remember, uh, change the parameters which actually are responsible for gradient descent, and these are okay, Vipul, perfect. So that's what, right? So but you should know the reason, right? Why वो हुआ क्यों विपुल 0.01 पे हुआ क्यों? Because आपने jumps अपने बढ़ा दिए to reach to that local minima or global minima. Okay, so that's why don't avoid changing the model layers or neurons, because that is something which indirectly impacts the gradient descent. You have to think कि directly कौन impact करता है. तो एक data scientist में और एक normal person में यही फर्क हो जाता है कि you should know what to tune. Otherwise you will jump in tuning everything. That's not good. Tune only that thing which is related to the problem that you have to solve. Okay, so guys, I think so far all of you are uh, up till this level. So please now do this. Let's predict. Let's do the prediction and see what's the accuracy. Guys, please check the accuracy if you're getting any. Coefficients or intercepts हमने देख लिए हैं. We know now. अच्छा, तो यहाँ तो आप एक्यूरेसी चेक नहीं कर पाओगे, क्योंकि हमने सारा का सारा डेटा जो है वो मॉडल को ट्रेन करने में यूज कर दिया. डायबिटीज वाला we had to split it and check it. Okay, what you can do, you can take any few records, just create the test data on the fly. Okay, I'm creating the test data here itself by passing in some of the random data to it. Okay, so you can also do that, copy it from the initial data set that you have. And I just want to check the predictions that the model gives. Not fitted error. Okay, wait. This MLP regressor is not yet fit. Okay. दिस इज द प्रॉब्लम. ओके, मैंने यहाँ बैच साइज जो 40 दिया मैंने कोट्स में दे दिया, तो वो मॉडल वहां पे फेल हो गया. सिंगल कोट्स में वैल्यूज दी थी मैंने, so model was not able to understand it. So model was saying string and integer में वो confuse हो गया. So now it's working fine. So my model is just running. Okay, so this is the model, but अभी इसमें convergence warnings आ रही हैं. I have to change the parameter. But yeah, this model I am now using to do the predictions. Now it's failing. Float argument is be a string or a number and not ellipses. You can use that original pre-processing wala train test split on this data also. Try once if that helps you, Aditi. Oh, okay. So here the problem is this ellipses actually. Can you check this? So how many features we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 features. I'm just checking, predicting only for single record, or you can predict multiple records. This is how you can do it. So guys, please do this. So now if you see the predictions are coming, I don't know whether it's accurate or not, but yeah, they are definitely different from each other. Just by changing one feature, I'm seeing different predictions. So definitely if I know their actual values, I can check the accuracy of the model. So guys, on the diabetic data, what you need to do is you can do the train test split, and then you can follow this approach. Okay. Or if you want, you can manually split and do this. NumPy has a lot of functions, additional functions also to do splitting and data shuffling. Okay, NumPy has its own functions also. But so far, guys, are you able to understand? Like this was my test data, 10 features and 10 features, like 2 rows मैंने पास किया और उससे प्रेडिक्ट करके देखा, ये मेरे प्रेडिक्शन लीनियर रिग्रेशन के प्रेडिक्शंस आ गए. So far, is there any doubt before we move into the next step? Any doubt? Perfect. So you know how your model will look like, how the weights will look like, how the iterations will happen, what are the hyperparameters, impacts of learning rates, solver, all those things. Okay, perfect. But now what I am saying is, whatever we done so far in regression, whether the Chennai water data or the diabetic data, we were using regression. Similarly, we have a classifier, MLP classifier. So you guys can look into that also. It's also similar. But now we actually don't use scalar neural network. So what we use is something different. So we are going to see that. So for regression, right? For regression, I'm talking about. Now for regression, I will be using the Keras, which we were talking about yesterday, even in time series model also. So Keras is one of the deep learning framework like PyTorch, TensorFlow, Theano, lot of other there, right? CNTK. So Python, like we particularly prefer Keras, and Keras internally supports TensorFlow. Okay, we can use PyTorch also. Let's try to install PyTorch if that happens, because someone from you told me they were not able to do that. So pip install PyTorch and see if it's working. That's another deep learning library we can use. So we are doing pip install PyTorch. So uh, guys, please try pip install PyTorch uh, and let me know if it's happening or not. I don't know for those who were not able to do it, what was the problem, but this is how you have to do it. And okay, so this is the problem. I think they may have faced this only. Okay, so let it run. So what it's saying, just look at the error. Okay, so the error is you tried to install PyTorch. The package named for PyTorch is Torch. So just now try Torch. Yeah, try Torch now. So it's trying it but not happening. So pip install Torch. If that does not happen, then I have third package. I'll tell you. We can try that. Pip install Torch. And if all that does not happen, then there is a Scorch. I'm just pinging you on the screen. Scorch. That's the sklearn version of Torch or PyTorch. So just do pip install PyTorch. If that doesn't happen, do Torch. Even if that doesn't happen, do Scorch. Okay. So whenever you install from the internet, it installs some tar files or wheel files and then builds it. Okay. So error building the wheel for Torch. No, wait. We'll go into that, Nishta. Thanks for pinging that, but we'll try that at the last. So if nothing is working, do the Scorch and you are good with that. However, there is one thing which Nishtha is pinging you, which is the another way of doing it. So you can use that also. What Nishtha is specifying here. That's also pretty much there. Sorry. It's like conda install PyTorch with the Torch Vision, Torch Audio. These are all the dependencies that PyTorch will need. So you are specifying all the dependencies and doing that. So if pip installs does not work, we can try conda installs, because this is Anaconda, and this is not only for these packages, this is true for other packages also. So try it out. Yeah, this is another package. Scorch is another package. This is another package, Nitika. They are different packages. Scorch is the sklearn version of it. But you may not need sklearn. You can directly work on PyTorch. That's what. These are two different packages actually. Scorch is the sklearn version of PyTorch. Okay. So coming back to this, you will come to know this is a very deep field in itself, or all these things. So now we are using Keras. We can also use PyTorch. We can also use Scorch, anything. Similarly, as we were using at the top, sklearn neural network, which is another way of doing it. So this is another way of doing it. Okay. So this is another way of doing the same thing. Okay. So now what we need to do is, once you have all these packages installed, from keras.models, you will just import a sequential as in a class. What the sequential class do, this helps us to just build this black box. Okay, so this is like your black box where in sequence you keep adding the layers. Okay, you keep adding the layers. Now if you want to do some RNN, LSTM, so you will say, okay, one of the layer is RNN or multiple layers are RNN. Similarly, in CNN, you can say, I want to use a convolutional layer. So there are different kinds of layers. But here we are talking about regression and classification, right? So regression and classification, you don't need RNN, you don't need LSTM, you don't need a CNN layer. You need simple layers, and dense layers are the simplest layers. So the layers that we will use are dense layers. Okay, we will not use the specialized layers. And dense word का मतलब ये है कि अगर मैं एक लेयर को कह रहा हूं कि भाई तुम डेंस हो, मान लो ये लेयर डेंस है, इसका मतलब ये है कि वो डेंसली कनेक्टेड होगी. Okay, that will be densely connected to the other layers and even to this layer, right? So dense connected layers क्या होती हैं? जो जिसमें हर एक न्यूरॉन एक लेयर का दूसरी लेयर के हर एक न्यूरॉन से कनेक्टेड होता है, उन्हें हम डेंस लेयर्स कहते हैं. ओके, सो dense layers is just a kind of layer, like LSTM is another kind of layers, RNN is another kind of layer. In RNN and LSTM, what happens is we have loops, but dense layers are simple feed forward layers. If your neural network contains all the dense layers, then it's a feed forward network. But if any of the layer in between is an RNN or an LSTM, then that entire network will now be a RNN or a LSTM network, not a feed forward network. Remember this. Okay, because I can have multiple dense layers and one RNN layer, that itself will make the entire network as an RNN network. Okay, so RNN neural networks, they have loops. What is this loops? They have memory. Okay, they have memory. Like in our brain, we don't have only processing, we have memory also, right? But feed forward networks were only doing processing. They were not remembering anything. उनके पास अपनी कोई याददाश्त नहीं थी. तो लेकिन जो प्रॉपर आरएनएन मॉडल्स हैं, जब मैं कहता हूं कि मैं आपसे कुछ बोल रहा हूं तो ऑर्डर मैटर्स, राइट? तो ऑर्डर अगर मैटर करता है तो मुझे एक एक वर्ड किस ऑर्डर में बोला गया है वो याद रखना पड़ेगा. मतलब मेरे पास कुछ मेमोरी होनी चाहिए, दिमाग होना चाहिए, स्टोरेज होना चाहिए. तो दैट्स व्हाई द आरएनएन लेयर्स और एलएसटीएम लेयर्स, दैट्स व्हाई देयर नेम इज एलएसटीएम. को क्या कहते हो? एलएसटीएम का फुल फॉर्म क्या है? लॉन्ग शॉर्ट टर्म मेमोरी. मतलब मेमोरी है उसमें. मतलब ये अगर लेयर आपकी एक आरएनएन लेयर है या एलएसटीएम लेयर है, उसमें कुछ मेमोरी होगी. ओके, मतलब वो इंफॉर्मेशन स्टोर भी करेगा. अब इसका मतलब क्या है? इसका मतलब ये है कि मान लो थोड़ी देर पहले मैंने एक रिकॉर्ड इस नेटवर्क के थ्रू पास किया था. ठीक है, एक रिकॉर्ड पास किया. जब आप मॉडल ट्रेन करते हो, आई एम कमिंग टू दैट गुलजार, जब आप एक मॉडल को ट्रेन करते हो, मान लो मैं कहता हूं 100 रिकॉर्ड्स पे ट्रेन कर रहे हो आप मॉडल को, राइट? 100 रिकॉर्ड्स पे. तो पहला रिकॉर्ड भेजोगे, फिर दूसरा भेजोगे, फिर तीसरा भेजोगे, इस तरह से आप 100 रिकॉर्ड भेजोगे. तो जब मैं सेकंड रिकॉर्ड भेज रहा हूं, उस समय पहले रिकॉर्ड की कोई इंफॉर्मेशन नहीं होती. फीड फॉरवर्ड के पास, वो भूल चुका होता है सब कुछ। लेकिन आरएनएन लेयर जो होती है वो इमीडिएट पास्ट वाला जो रिकॉर्ड थोड़ी देर पहले गुजरा होगा वहां से, उसके फीचर्स की पूरी इंफॉर्मेशन उसके पास स्टोर्ड रहेगी। तो आरएनएन मॉडल्स आर नोन एज शॉर्ट टर्म मेमोरी। आरएनएन मॉडल्स और लेयर्स आर शॉर्ट टर्म मेमोरी because they were only saving the information up to the last record. While processing this, उसको ये याद था कि उससे पहले क्या रिकॉर्ड गया था। But consider while processing the 99th record, I want to know all the information say up till the 50th record. So much information. So I need a long short-term memory. A long duration short-term memory. मतलब वो शॉर्ट टर्म मेमोरी जो लॉन्ग ड्यूरेशन तक इंफॉर्मेशन सेव कर सके। मतलब पिछली 50, 60, 100 ट्यूनेबल है वो, तो वो आपके एलएसटीएम मॉडल्स हो जाते हैं। गाइस समझ आया आरएनएन और एलएसटीएम होता क्या है एज कंपेयर टू अ सिंपल लेयर? इसके अंदर डिटेल की अभी एंड नहीं है कोई, अभी मैं बहुत ऊपर से बता रहा हूं, ठीक है? बट दिस इज व्हाट आरएनएन एंड एलएसटीएम आर, एंड वी विल open up these neurons, we will open this neurons and see कि उसके अंदर है क्या, we will open it later, but this is what RNN and LSTM are. and RNN and LSTM का मतलब ये नहीं होता है कि सारी लेयर्स ही उसमें वो होंगी। आप एक भी लेयर अगर LSTM डाल देते हो तो आपने एक तरह से उस लेयर पे ऑर्डरिंग मेंटेन कर ली, तो आपका पूरा नेटवर्क एक तरह से ऑर्डर्ड हो गया। ओके, तो लेयर्स कैन बी ऑफ मल्टीपल टाइप्स। So if you look here, the type of layers can be convolutional layer, convolutional 1D, 2D, 3D, convolutional LSD, LSTM, dense layers, max pool is another kind of layers. Grooves is gated recurrent units, So I'm just saying you these are all layers. Input layer is not a layer, but it's just to specify the input. So pooling is another layer, recurrent is another kind of layers, recurrent. So इसमें सारी layers नहीं है, कुछ layers हैं और कुछ activation functions हैं। So these are your different kinds of layers, okay? So now वही same problem जो अभी हमने solve की, let's solve it through Keras. So from Keras.models, we have sequential model, and Keras.layers, we have a dense layer. So now the same data, the diabetes data. But what I need to do now is very simple. I'll put this notebook. This is what I will do. जो मैंने time series में भी किया था. Model equal to sequential, and now I am adding the layers. I'll put this file on GitHub after this class. So I am adding 3 dense layers, guys, if you see. But here the last layer is the output layer. Okay, यहाँ पर हमें last layer बतानी पड़ती है, जबकि SQL में last layer बतानी नहीं पड़ती थी। यहाँ last layer आप बता रहे हो। Okay. This was the LSTM that we did in the time series. And there, if you see, what I did was, again, the sequential model, matlab the model having sequential layers, I was adding LSTM and then finally a dense layer. It was a 2-layer network, a LSTM and a dense layer. But this is when I'm solving a time series problem, okay, a time ordered problem. But regression and classification is not like that. So that's why when I'm doing it, I have to do this. तो मतलब देखो, न्यूरल नेटवर्क को नहीं पता है, न्यूरल नेटवर्क को नहीं पता कि मुझे क्लासिफिकेशन करनी है या रिग्रेशन करनी है। याद रखो, न्यूरल नेटवर्क्स डज नॉट नो दैट। इट्स नॉट लाइक रैंडम फॉरेस्ट रिग्रेजर, रैंडम फॉरेस्ट क्लासिफायर, जिसको पहले से पता होता है कि मैं रिग्रेजर हूं या क्लासिफायर हूं। गेटिंग इट? इवन अभी आपने ऊपर भी अगर देखा, यहाँ पर भी आपके लिए अच्छी बात क्या थी कि एसकेएलएन ने वो अपनी पुरानी आदत नहीं छोड़ी कि न्यूरल नेटवर्क में भी बोल दिया भैया तू रिग्रेजर है, तू क्लासिफायर है। बट ऐसा होता नहीं है। न्यूरल नेटवर्क्स डोंट नो whether they are regressors or classifiers. Okay, it's you who need to tell them what they need to do, because for them everything is neuron and the entire game is around the activation function. Okay, so all the game is for the activation function, nothing else. So if you have to do a regression, you will use a linear regression types activation function. If you have to do classification, you will use sigmoid or you will use softmax, that kind of a activation function. But the important thing is, if you have 1 layer, 2 layer, 3 layer, this is input layer. Okay, I'm not counting that, and say this is your output layer. Okay, अगर आपको रिग्रेशन करना है तो आपको हमेशा आउटपुट का डिसाइड करना है कि क्या एक्टिवेशन फंक्शन होना चाहिए। ओके, आउटपुट का क्या एक्टिवेशन फंक्शन होना चाहिए। अगर आउटपुट का एक्टिवेशन फंक्शन एक लीनियर फंक्शन है तो आपको कंटिन्यूअस नंबर्स मिलेंगे। अगर वो एक सिग्मॉइड है या एक स्टेप फंक्शन है तो आपको 0 और 1 मिलेंगे। बट इंटरमीडिएट लेयर्स के अंदर आप कोई दूसरा एक्टिवेशन फंक्शन रख सकते हो। रिग्रेशन के केस में आप अंदर सिग्मॉइड भी रख सकते हो। अगर रिग्रेशन है तो अंदर सिग्मॉइड हो सकते हैं, कोई प्रॉब्लम नहीं है, because consider it like a feature, right? You can have 0 1 as features, right? Even in case of regression also. So if this neuron is giving value as 0 or 1, what's the problem? Means you can still have a regression model which have some variables with discrete values, right? Similarly, if you are doing a classification and here you have a sigmoid curve, okay, or you may have a step function, but internally you can have a ReLU, you can have a linear function, because for classification your inputs can be numerical, right? So consider it like that. The whole game is about the output layer. What is the activation function you are using? The output layer decides whether it's a regression or a classification. Neural networks does not know otherwise. Okay, so if you look here, the last layer which is having one neuron, so this one neuron, you are saying it's a linear activation function. So what we will do, same problem, same data set, we will use it as linear and then we will change it to say a step function, and you will see the output will change. Okay, it becomes 0 1 0 1, because neural networks are like machines, have some logic. It's you who needs to tune them. वो तो केरास की वजह से चीजें बहुत आसान हो गई, नहीं तो टेंसर फ्लो पे अगर आपको कोडिंग करनी पड़ती तो you had to go deep dive and create all these metrics, data level metrics. Okay, so understanding this, we know that there are 2 hidden layers and 1 output layer, 16 neurons, 8 neurons, the activation functions, right? Here also, but here we have one additional parameter which is input shape, because यहाँ पर आपको इनपुट भी बताना है, जैसे यहाँ आउटपुट बताना है आपको इनपुट भी बताना है। एसकेएलएन में वो भी नहीं करना था आपको, यहाँ आपको बताना है। कैसे बताना है? आपको सिर्फ ये बताना है कि आपकी इनपुट की डायमेंशन क्या है, इनपुट की शेप क्या है। 3 कॉमा मतलब 3 कॉमा एज इन यू हैव 3 फीचर्स दैट यू आर पासिंग इन द मॉडल। कॉमा के बाद यू डोंट स्पेसिफाई एनीथिंग, दिस इज व्हाट यू स्पेसिफाई। 3 comma as in 3 features I have. So this is the way you specify. So SQLN में आपको 2 काम बच रहे थे, यहाँ वो दोनों काम आपको करने पड़ रहे हैं। You have to specify the input layer, but since input is not actually a layer, you are not adding it anywhere. You are just specifying it to the first hidden layer by कि तेरे को इस तरह का input मिलने वाला है। वो कहेगा चलो ठीक है, that's fine. It makes sure कि उतने weights वो बना के रख ले। Okay, so Do this, guys. Do this parallelly with me. 1 second. Do this parallelly. Just hold on to the questions because I need to complete this and then we will take the questions. Just 5 minutes I'll take and I'm done. So just take this up, run this. And now after that, what we are going to do is we have to compile this model. Means अभी तक सिर्फ layer add हो रही थी, अब हमें actual model build करना है. अब जब आप actual model build कर रहे हो तो अब आपको loss function बताना है. अब यहाँ भी important है. क्या important है कि अगर आप regression problem solve कर रहे हो तो आपका loss function can be mean absolute error or mean squared error or SSE, squared sum of errors. But if it's classification, this needs to be cross entropy. Okay. Optimizer, this Adam optimizer is only when you talk about this thing, the mean absolute error kind of the things. These values also changes for classification. Matrix, as in which all matrix you want this model to compute. Though you are using mean absolute error as a loss function, but whenever the iteration will happen, you want model to also print this, so it just keeps printing you mean squared error also. So you just want this metric also to be printed, and then you will fit the model. And while fitting, you will say epochs like the iterations, the batch size, whether it's mini batch. If you say it's 1, then it becomes stochastic gradient descent. Verbose as in the data, and validation split. मतलब ट्रेनिंग डेटा का 20% वैलिडेशन के लिए रख लो. टेस्ट डेटा तो आपने पहले अलग कर दिया था, अब ये जो आपने ट्रेनिंग डेटा भेजा है उसका 20% आप वैलिडेशन के लिए अलग रख रहे हो. Okay. So now my model is just running. So this is first epoch. I think Gulzar, you might have seen this when you may have logged in the class. So if you see, this is like gradient descent is happening. I'm jumping. My loss function is adjusting at each step. See, this is one of the iteration in which multiple jumps are happening and multiple loss functions are being tried till something happened. Okay. So if you see here, I'm just doing 10 epochs and 452 are my records in this particular data. So let me change this data. So we took this as the data. Yeah. So what I'm saying is I'm changing this with the diabetes data that I have, the diabetes data that was with me. So I'm again running this, but what happened? Input 0 of the layer, sequential 1 is incompatible with the layer. Okay. Can anyone read it and tell me the error? What do you understand by this, guys? Before I tell you, what do you understand? It's very clearly specifying the problem. Guys, any idea what the error is? It's very simple. Okay, Rahul, what others think? Yeah, but what is the issue? Yeah, Vipul, good. Anyone else? What this error is? Input shape doesn't match. Yeah, a layer incompatible. Okay, okay. So all of you are correct. See, what it's saying is this is a sequential model, as in the sequential layers. So it's talking about the layer 1, which is primarily the input layer. It's saying that the dimensions should be 3, but it received 10. Here, if you see, it's saying it should be 3, but it received 10. So yes, because diabetes data has 10 features, right? Not 3. So I have to pass 10 here, right? I have to pass 10 here. Okay. And as soon as I do this and then I run it, it's running. Okay. So now it's running. So ये छोटी छोटी सी जो errors हैं, you need to understand and resolve them. Okay. I'm just looking at this 36, okay, before I tell you what this 36 is. But before that, just have a look at it. Like you said, say 100 epochs, let's increase this. And batch size is say 9. Let me run it again. So 100 epochs needs to run. And yeah, it's running 100 epochs. Okay. So 100 epochs are running. Let's talk about one of the epoch, which is this. So this epoch, I need to find what is the loss function. So this is the loss function here during this epoch. This is your mean squared error as I wanted it to print, right? Mean squared error also, because loss here is what? MAE. Loss here is MAE, mean absolute error. But I also wanted mean squared error, so it's printing me that. And what is this? Can anyone tell me what this logically means? This, जब मेरे पास यहाँ loss और MSC आ गया, तो ये val loss and val MSC क्या है? Can anyone tell me? That's निष्ठा करेक्ट, या गुलजार करेक्ट. ये जो वैलिडेशन डेटा है उस पे, ये किस पे है? ये ट्रेनिंग डेटा पे है. और ये किस पे है? ये वैलिडेशन डेटा पे है. तो मुझे ह्यूज मिसमैच दिख रहा है यहाँ पे, राइट? देयर इज अ कंसिडरेबल मिसमैच बिटवीन द वैलिडेशन डेटा, मतलब लॉस एंड दिस थिंग. So model will keep training till the last. Let's see how much it went up till. So this range is somewhat decreased. Even the error decreased, the range decreased, the difference between them decreased. So model is becoming better. Yeah, Aditi, correct. Okay. So this is about how to read the particular stuff. Now coming to this 40 out of 40. Can anyone tell me what is this 40 out of 40? Logically, any guess what this 40 out of 40 is, or what it could be? Because I'm not able to recall, to be very frank. So I'm just trying to deduce it. I'm trying to identify it logically what it will be. Guys, please think, because data science is not like you learn it and it's done. You have to think what it could be. This value is decreasing with the increasing this. Units in all the layers. No, how that can happen, Karan? Your units cannot change, right? As in the neurons, right? You are saying the number of neurons. Number of neurons cannot change, right? Number of neurons is like 2 into 3, that's 6. So that will always be 6. But abhi ye thodi der pehle 40 tha. And this value, number of random records. Okay. Data in one epoch. So the data in one epoch is actually the batch size, right? 59. then how can it be 6? Getting it? Data in one epoch that I'm asking is of the batch size like 59. How can it be 6? Total jobs in the Hadoop. Hadoop? Aditya, it's not Hadoop. Okay, I'll leave up to you guys also. Please try to identify what this means. Okay, do one thing. 36 into 10, right? 36 into 10 is like around 360, right? Okay. Let me make it 40 to conclude my. Okay, let me make it 100. And if it's coming to 4, then it's fine. If this value comes to 4, then it's fine. Okay, it's 4. Okay. So what's happening is it's somehow this batch size is computed by this, like this is 400 and this is 100, so it's divided and get to the ceiling value. Okay, so that's what 4 is. But why is it so? So that means in the one epoch, how many total batches are getting created? If I am saying create the batches of size 400, 100, 100, then out of this entire data, how many batches you can create out of it? So you can create like 4 batches out of it, right? And then your model is running on all of those 4 batches. I'll tell you the relevance of this, why this happens, but first of all, did you get it? Like what's happening here? Your input data, whatever is your input data, that's divided based on the batch size. So let me pass it 300. And for 300, it's splitting it 300 and then the remaining one. जितने भी रिकॉर्ड्स है वो दूसरे बैच में. So just to tell you कि इसका मतलब क्या है. Okay, I'll explain you in the 4 jobs. So it's something like that. It may be Aditi. It may be something like that. Number of jobs, but I'll tell you that in the next class more about it. Yeah, number of batches. But my point is, what's the relevance of that, right? So I need to first look into it before I tell you about this. Because ultimately, if I'm talking about the gradient descent, what's happening, right? This is what my curve is. So I'm saying that like in the first iteration or the gradient descent, it's just, this is like the first jump that is taking, right? And then I'm giving it some sample, like a batch size of 300 is the number of record that it should use to do all the computation for this particular iteration. But why the remaining data is being used, I'll tell you. Okay, you can also read about it. We can discuss this in the next class. How this batch size is actually getting used here. So that's one of the thing. So that's an assignment for you guys. Just read about this. Read about the Adam optimizer, how Adam optimizer is different from stochastic gradient descent, SGD. So read about that. Okay. So we saw that validation is directly impacting that value which is coming over here, but why it's happening, so we'll discuss. Okay. But now the important thing for us to see is the gradient descent process happened, and finally we get a loss value, and then we can again see the parameters of this particular model. Sequential model has no attributes model. Okay, so where is it? Okay, Varsha. So it's like, yeah, within one epoch, how many iterations are happening? Multiple or multiples of that. So that's one of the additional thing that happens in neural networks, where epochs contains multiple iterations, but we'll discuss about that in detail. You are right, Varsha, actually. But I'll tell that in the next session. It's something additionally to be told. So guys, yeah, okay. So there is this summary function available to us, which tells us like how many layers we have, what is the shape of the layers, right? Total how many parameters this model must have built internally, like all the connections that happened internally in this. There must be some biases also additionally. So we'll talk about this also in detail, how to interpret this, how to see all these parameters. But yeah, as the number of layers and the number of neurons increases, your parameters will keep increasing. So for example, we have 10 inputs. So we have 10 inputs, right? And 10 will get connected to the 16. So it's like 160 तो वहीं हो जाते हैं आपके, प्लस हर एक न्यूरॉन का अपना अपना बायस, तो 176. गेटिंग इट? ये 176 कैसे आ रहा है गाइस? इज इट क्लियर कि इनपुट लेयर में 10 फीचर हैं, यहाँ 16 हैं, तो डेंस लेयर है तो 160, और हर एक न्यूरॉन का अपना अपना बायस, तो 176. तो ये 176 वेट्स नहीं है, 160 इसमें वेट है और 16 इसके अंदर बायस है. ठीक है, तो ये पैरामीटर्स में मतलब वेट और बायस दोनों है, मतलब इंटरसेप्ट और स्लोप दोनों है. फिर 16 से 8, तो जस्ट मल्टीप्लाई 16 इंटू 8, कितना होता है? कैन एनीवन टेल मी? 16 इंटू 8, आपके पास नोटबुक है, वहीं पे आप देख सकते हैं. 128, और 128 में आप 8 बायस जोड़ दो तो कितना हो जाता है? 136. तो आई होप यू आर guys now knowledgeable enough to understand neural networks, at least to understand the layers, the network parameters, the bias parameters and the weight parameters, how these are getting computed. And you know, if you see dense, what is the meaning of a dense layer? Okay, so these are all the things. Yeah, Gulzar.
सर एक बार वो कंप्यूटेशन डिस्प्ले करना भी, जिसमें 16 और 8 और 128 जो 126 सर, इसमें एक नेक्स्ट लाइन में हम जैसे जो 7th डेन 7 की जो लाइन है, उसमें हमने डेन 6 को डेन 7 से आउटपुट शेप को मल्टीप्लाई करके उसमें डेन 7 की वैल्यू ऐड की है.
देखो होता क्या है, अगर आपकी ये एक लेयर है जिसमें 2 न्यूरॉन्स हैं, ये एक लेयर है जिसके अंदर मान लो 3 न्यूरॉन्स हैं, तो टोटल कितने पैरामीटर्स होंगे मेरे पास? 2 मल्टीप्लाइड बाय 3, मतलब 6 तो वेट्स हो जाएंगे, मतलब 6 वेट मतलब 6 तो कनेक्शंस हो जाएंगे मेरे पास, राइट? राइट
सर ठीक है.
लेकिन हर एक न्यूरॉन का अपना अपना एक बायस टर्म भी होगा, B1 B2 B3, तो वो 3 वो ऐड हो गए यहाँ पे, तो टोटल 9 पैरामीटर हो गए जो आपके मॉडल को लर्न करने हैं.
ठीक है सर.
राइट, तो अब इसमें क्या था, 10 तो आपके इनपुट लेयर पे थे और 16 आपके फर्स्ट हिडन लेयर पे थे. तो 10 इंटू 16 160 और हर 16 का अपना बायस, तो 176 हो गए, राइट?
सर एक बार फिर से कहना, वो 10 कहाँ से आया है?
ये 10 तो मेरे फीचर्स थे ना, 10 तो आपके फीचर्स थे इनपुट लेयर में,
ठीक है सर।
तो वो भी तो कनेक्ट होंगे आपके फर्स्ट लेयर से डेंस डेंस वे में, राइट? ओके, ठीक है। तो 1 सेकेंड, सो दिस इज अबाउट इट। एंड मतलब न्यूरल नेटवर्क्स में epoch is something quite smart word, which is internally having iterations, multiple iterations, which we will talk about. And this batch size actually controls the number of iterations within each epoch. So we will talk about that. If you make batch size equal to the number of records you have, like whatever you have, so there is only one epoch. Okay, so there is only one epoch that will run, because सारा डेटा मतलब हर epoch के अंदर सिर्फ एक ही iteration होगा, क्योंकि सारा डेटा आपका कंज्यूम हो जाएगा. we will talk about that in detail. बट ये सारी चीजें आपके ग्रेडियंट डिसेंट और कन्वर्जेंस को कंट्रोल करती हैं. ओके, so we are now aware about all these terms, keras and all. There are different kinds of layers. Please read about it. यहाँ पे भी वही है, फिट किया फिर हमने प्रेडिक्ट कर लेना है इसको. ओके, 1 second. So we did the fit, and then we will use the predict function and predict the value, and then we will get the R square value. Okay. So this is about the regression. Please try it again. So we took 2 data sets, one the diabetes data, another was the Chennai water prices data. You can try other data sets also. Similarly is the MLP classifier. MLP classifier, if you open, also have the hidden layers, activation functions, solver, everything. Okay, it also have those similar things, but the difference will come in the output layers. The number of neurons in the output layer will be decided by the MLP classifier automatically, based on whether it's a binary classification or it's a multi-class classification. That's how it happens. So MLP classifier is intelligent enough, but Keras is not intelligent in that sense. Though Keras is much more powerful. Keras is far powerful, but Keras does not have anything. Keras में आपको यही करना है, क्लासिफिकेशन में भी आपको यही करना है, बट आपको क्या करना है, इस चीज को चेंज कर देना है. इसको क्या कर देना है, लेट्स से यू मेक इट sigmoid or you make it logistic, you change it. Okay, and then you try to predict it. But again, the problem is, first I am saying mean absolute error. I have to change it to cross entropy, right? Because sigmoid also gives you percentages between 0 to 1, तो ये fail नहीं हुआ. Okay, but let's see अगर step function रहता है इधर. तो स्टेप फंक्शन इसमें है ही नहीं, इसलिए वो पता नहीं, मतलब यहाँ एरर आ गई, फेल हो गया. तो अगर हमें वो चेक करना है, व्हाट वी विल डू, वी कैन गो बैक what are the possible values. How will you get import site dot get site packages, go to this path, open the keras, and in the keras what you need to check for the activation functions. So we will check what are the activation functions available in the Keras. Here we have the activation functions. Guys, please, you can also open this and check softmax, relu. So step function is not available. Let me try softmax. So all of these are working because of, again, first of all, mean absolute error and then this target. Okay, so now the data that I need to train on should also contain values like 0101. So I will change this also. I need to change this also. I need to change this also to entropy. So then what I need to check, what are the loss functions which are available, right? So how will I get to know these loss functions? I again go back. Okay, I'll again go back and here we have losses. Okay. So there are multiple losses available here. So from TensorFlow.keras import everything. Okay. So it's not specifying me that thing. So that I can again check here. But before I go into that, I would say that I'm done for the day. Those who want, they can leave, but I'm just telling some additional things which are out of your syllabus. But yeah, those who have some work, they can leave. Maybe. Okay, those who want, they can leave, and those who want to stay, they can stay to just check how to check these things behind the scenes. So for example, what are different loss functions? I want you guys to do it in parallel. Yeah, Nishta, next class is on Monday, morning only, 10 to 1. So guys, please, can anyone check and tell me all the possible values? So see what it's doing is, it's saying inside this Pi class, there is this TensorFlow dot keras. So we have to go in another package, which is TensorFlow package, means keras is underlying using TensorFlow. So I'm going inside TensorFlow, and in TensorFlow, it's saying go inside keras. So I have this keras here, right? I go inside keras. Further, it's saying go inside losses. I'm going inside losses here. And here there is this init. I'll go inside this init and I'll check it. So when I'm here, you see here, whether it's a binary cross entropy, means two class classification, whether it's categorical cross entropy, which is multi-class classification. Okay, so you use these two primarily. These are the two losses, the loss that we use for categorical problems: binary cross entropy and categorical cross entropy. For numerical, you can use mean absolute error, mean squared error, as I told you, MAE, MSC, or even you can use a squared error also. So these are some of the important things. Like you have binary cross entropy, categorical cross entropy. For numerical, we have MAPI also, right? Mean absolute percentage error, MAPI. You guys must have heard about it. There is something known as hinge loss, Huber loss. So these things I cannot definitely teach everything, but yeah, I want you guys to read about these. These are important things. What is hinge loss? What is Huber loss? At least these ones are important. What is squared hinge loss? What are cross entropies? These are important. Okay, just read about this. Cosine similarity is one of the similarity metrics for categorical kind of data that we use. So read about these different loss functions. Okay. सारे पढ़ने की जरूरत नहीं है, जो 3-4 मैं बोल रहा हूँ वो पढ़ लेना. Hinge loss, square loss, Huber loss, cosine similarity, okay, categorical hinge, all these things are important. Okay, so guys, yeah, so you have to simply pass that value here कि भाई ये मेरा categorical cross entropy है या binary cross entropy है, और accordingly आपका ये value यहाँ पे वो वाला कॉलम आएगा जिसमें 0101 का वैल्यू आएगा, ये मेट्रिक यहाँ से हट जाएगा और ये ऑप्टिमाइजर भी हट जाएगा. for categorical. Okay, so you can use iris data to do all these things if you are interested. So iris data use करके देखना, लॉस फंक्शन में आप ये वाले लॉस फंक्शंस डालना, बाइनरी क्रॉस, वहां पर बाइनरी नहीं है, वो कैटेगोरिकल क्रॉस एंट्रोपी है, राइट? जो आपका आइरिस डेटा है, मल्टी क्लास क्लासिफिकेशन है वो. ओके, सो जस्ट ट्राई इट आउट. सो डू दिस रिग्रेशन तो हमने कर लिया. क्लासिफिकेशन में जो मैं आपको बोल रहा हूँ, ट्राई विद दिस एमएलपी क्लासिफायर ऑल्सो एंड द अनदर वन ऑल्सो, केरास के थ्रू भी, बट यू हैव टू do multiple things. And then in the next class we will first look at this classification problem, and then we will start RNN and LSTM. Okay, any questions? So Aditi, yeah, ask the questions right now only. Tell me.
ओके सर. सर ये जो MLP रिग्रेसर था, इसमें हमारा जो आउटपुट लेयर है उसमें हमेशा 1 न्यूरॉन रहता है.
In MLP regression always 1. In MLP classifier it depends on the multi-class classification है, तो ज्यादा होगा, नहीं तो एक होगा, 2 होंगे. ये कैसे काम करता है? क्लासिफिकेशन कैसे काम करता है कि आपके आउटपुट लेयर में मान लो 2 आ गए, 2 न्यूरॉन आ गए. दिस न्यूरॉन इज फॉर से लोन देना है या नहीं, मान लो यस और नो. ठीक है, तो अब क्या होता है कि व्हेन द आउटपुट विल कम, द आउटपुट विल, इट्स लाइक स्विचेस ऑन एंड ऑफ. तो जहां देना है, दिस स्विच विल बी ऑन एंड दिस विल बी ऑफ. दैट मीन्स दिस विल गिव यू 0, दिस विल गिव यू 1. ओके, और अल्टीमेटली इसका आउटपुट जो आता है अदिति, वो ऐसा ही आता है जैसा आपका प्रिडिक्टेड प्रोबेबिलिटी में आता है ना. आपका एक्चुअली एक इसकी प्रोबेबिलिटी निकलती है, किसकी निकलती है. तो आपके पास मान लो निकला 0.7 एंड 0.3. तो दैट मीन्स 0.7 मतलब फॉर दिस, 0.3 मतलब फॉर दिस. तो यू कैन से कि हाँ दिस इज यस और नो, लाइक दैट.
ओके सर. सर यही था, मुझे रिग्रेसर वाला पूछना था मेन.
हाँ,
एंड
हाँ,
वो
हाँ.
क्लासिफायर जो है वो खुद से डिसाइड कर लेता है ना कि कितने न्यूरॉन्स होने चाहिए बेस्ड ऑन कितनी क्लासेस हैं.
It decides in the case of this thing, MLP classifier.
Yeah, right.
Right?
Yes, sir.
But it does not decide this in the case of Keras. In the case of Keras, you have to specify that, because what Keras is doing, see. So what Keras is doing, you have to specify the output, okay, based on the number of classes you have. And here also you have to specify whether it's binary cross entropy or it's categorical cross entropy.
Okay,
Right,
sir.
Aditi?
Yes, sir.
मतलब making sense, right?
Yes, sir. Yes, sir.
बिकॉज अगर आपने यहाँ पर दे दिया मान लो बाइनरी क्रॉस एंट्रोपी और यहाँ 3 दे दी आउटपुट लेयर, तो वो आपको प्रॉब्लम देगा. यहाँ आपने 2 दे दिया और यहाँ आपने कैटेगोरिकल क्रॉस एंट्रोपी दे दिया, तो वो फिर भी चल जाएगा, बिकॉज सुपर सेट हो गया ना कैटेगोरिकल, तो 2 को भी अलाउ कर देगा वो. बट आइडली यू नीड टू मेक श्योर कि अगर यहाँ 2 है तो आप डायरेक्टली यहाँ बाइनरी यूज करो, अगर 2 से ज्यादा है तो यहाँ कैटेगोरिकल यूज करो, क्रॉस एंट्रोपी. ठीक है?
यस सर. थैंक यू सर.
ओके, क्रॉस एंट्रोपी का फॉर्मूला बाय हार्ट कर लेना, जैसे आप एमएससी या एसएससी का आप लोगों को करा हुआ है आप लोगों ने. क्रॉस एंट्रोपी का भी याद रखना. एनीवन, एनी अदर क्वेश्चन गाइज? please practice this. I will not repeat it in the next class. I may directly jump in RNN and LSTM. So I am saying you have to practice both of these. Okay, and if you face any issues, we will discuss. But we may start directly with RNNs and LSTMs. So please practice this and read about the different deep layer frameworks. Okay, so if no questions, guys, we'll end the session here only. Thanks for your time. Damini, you can close the session. Okay, thanks everyone. Thanks Karan. Thank you. Yeah, I'm doing that. I'm uploading this file in another 2 minutes. I'll organize it and upload it. Okay, thank you. Thanks a lot.